So we've officially done all of the methods that you can use for solving a quadratic. We're fresh off the quadratic formula. Today we're going to be looking at a part of the quadratic formula, which is called the discriminant, and I'm going to show you how you use this thing that's called a discriminant. So before we kind of get into what that word means, let's review solving using the quadratic formula. Remember, the quadratic formula has to equal 0. So if I was given this first quadratic here, I would add the 1 over to make that happen. Then I would say a equals 1, b equals 2, c equals 1. And I would go ahead and plug it on in. So my values of x equal the opposite of b, negative 2, plus or minus the square root of b squared minus 4 times a times c. All of that over 2 times a. Remember that we then figured out what was underneath the square root as well as what number's on bottom. You can plug in underneath the square root exactly like it looks, parentheses and all. Okay, so that nicely just came out to be 0. I know that the square root of 0 is just 0. So I'm just going to write 0 right there. 2 times 1, that'd be 2 on the bottom. Okay. If I add 0 to something, doesn't change it. If I subtract 0 from something, it doesn't change it. So really, I don't even need to write plus or minus 0 because that's going to do nothing. So I'm going to cross it off, and I can see that I really only have one answer. Negative 2 divided by 2 is just negative 1. So that's my only answer. I solved it for x. Now, this kind of builds and leads into what we're talking about today, which is, like I mentioned, something called the discriminant. Now, the discriminant it's just a number. So the discriminant will equal 5. It will equal negative 32. It's just a number that it's represented by the expression b squared minus 4ac. You should recognize b squared minus 4ac. If you look up at the quadratic formula, that is exactly what's sitting underneath the radical right here. Okay, that is called, just that part underneath the radical, that is called the discriminant. Okay, so like I said, it's what sits underneath the radical in the quadratic formula. It has a name, who would have thought? Now, when you work out this b squared minus 4ac to get the number that it equals, this number tells us something. It tells us the number of solutions that a quadratic will have. It does not tell us that the x value equals 1. I'd have to do the entire quadratic formula to get that answer. The discriminant would have just told me on this first example that there was only one answer. Not that there was 2 or no solution. This only had one answer. Okay, so here's how you analyze that number to tell you how many solutions there are. This is what is very important for today. Put little brackets around it. You have 3 options when you use the discriminant. Okay, the first option, if the discriminant number, or the number underneath the radical, that's all I'm focusing on, if that number is a positive number, then the quadratic is going to have 2 different answers. If the discriminant equals 0, then the quadratic is only going to have one solution. And that's exactly what happened up here, you guys. b squared minus 4ac, when I put that in my calculator, I got 0. And we decided adding or subtracting 0 onto something doesn't change it. So I really only had just something divided by something. That only gave me one answer. But if the discriminant would have been like 16, say, then I would say the square root of 16 is 4, and I could have added on 4 to negative 2 or subtracted it, and that would have given me 2 different answers. Okay, so if the discriminant was like the review problem, just 0, there's only one answer. And then your third and final option is the discriminant being a negative number. Which, think about that, if underneath the radical sits like a negative 25, I can't do that. So that's the case when there's no solution. Okay, so that's kind of the big idea for today. And it makes complete sense if you think about when you're solving the quadratic formula. It's less work than solving the quadratic formula. So let me show you how we're going to use this. And be careful, people do way too much work on these problems. The directions just say find the number of solutions. So you're not telling me, oh, x equals 3/2 and 5/2. Don't say that. You're just telling me there's 2 solutions, 1 solution, or no solutions. You're not telling me the answers, you're just telling me how many answers there are. Okay, do not do too much work. Don't do the whole quadratic formula, just do the discriminant. Okay, so I'm just going to do b squared minus 4ac on all of these. Okay, so for this quadratic, a equals 5, and hopefully you don't even have to do this part, but for the sake of the first problem, I will. b equals 12, and c equals negative 32. So b squared, that'd be 12 squared minus 4 times a is 5 times c is negative 32. You don't actually have to take the square root of it, just do b squared minus 4ac. That's 4 times 5 times negative 32. Okay, so that equals 784. That's not your answer. I just used that to decide how many solutions there are. This was a positive 784. Okay, if the discriminant's positive, there's 2 solutions. So that's my answer. There are 2 answers that I can plug in for x that actually make this equal 0. I don't really care about what they are. I just know that there's 2 of them. Okay, number 2, same thing. So I'm going to do b squared minus 4ac. I'm not even going to write down a, b, and c because we should be good at that by this point. b is 3 minus 4 times a times c. Okay, so same thing. Just take it to your calculator. And I get negative 103. Okay, again, think about it. Negative 103 would sit underneath the radical in the quadratic formula. When you go to square root that, you cannot take the square root of a negative. So if the discriminant is a negative number, there's no solution. So you could just say 0 answers, you can write no solutions. Means the same thing. All right, on the back, you're going to do number 3. I'm going to do number 4. So b squared, make sure you use parentheses around the negative 12, otherwise you will get that wrong. Minus 4 times a times c. And I get 0. Okay, this is like the review problem. What's underneath the radical is just 0, so I'm only going to have one answer. It says it down here on case 2 as well. Okay, so that's not too bad. Again, don't do too much work. Now you're probably thinking, well, why does that matter? Why do I care about that? Why can't I just solve it and show what the 2 answers or the 1 answer is? Well, here's how you can apply the discriminant. So the situation on this word problem is a toy rocket is launched off of a roof with an initial velocity of 70 feet per second. The height of the rocket during its flight is given by this formula right here. The 70, them telling you that at the beginning, was just telling you where this 70 came from. All you should really focus on is the formula. The question I want to answer is, will the rocket ever reach 100 feet in the air? I can use the discriminant to tell me yes or no here. Okay, I'm going to use my lovely art skills to draw a little picture. Okay, so I got a little rocket. Beautiful drawing, I know. That's a rocket. Not a cursive L. That's a rocket. And the rocket's going to be launched off of the roof. Going to look something like that. Makes sense. I know it's an upside down U because it's a negative value in front of the squared term. So that kind of makes sense. I want to know, is it ever going to actually reach 100 here? So maybe its highest point, is it going to be 100? Is it going to be 100 before that? Like, will it hit 100 on the way up and on the way down? I don't know. I want to figure that out. So here's what I'm going to do. We need to put 100 in for h. Since that's the height, I'm trying to decide if it reaches or not. So when I plug 100 in for h, here's what it looks like. I know that when I'm solving a quadratic, I need to have it equal to 0 though. So before I kind of like work out the discriminant and I think about my yes or no answer, I need to move the 100 over to the other side. So I do actually have it equaling 0. So when I do that, 21 minus 100, those are the two I would subtract, both the plain numbers. I would have negative 79. Okay, so this is the equation I now want to use. Hopefully you followed that okay. Realize that this equation is specifically linked to me wanting to know if it's going to hit 100 feet off the ground. If I wanted to know any other height, it would look different. Like for example, if I wanted to know when the rocket was going to be 50 feet above the ground, I would plug in 50 for h, and it would look something like this. I'd go back to the original, put 50 there, and I'd have to move 50 over. Okay, so what I'm looking at right here, this is specifically about 100 feet. Now, I can use the discriminant to tell me if there's going to be solutions. Okay, I'm going to do this b squared minus 4ac. If it's positive, then I know that I'm going to reach 100 feet 2 different times. It's going to reach it once on the way up, once on the way down. If it's 0, I know that I hit 100 once, which would probably tell me that that's the highest point. That was like the vertex. And if I get a negative, that's going to tell me that I never reach 100 feet. So let's find out. Okay, so again, I'm looking right here where it's equal to 0. So b squared, b is 70 minus 4 times a is negative 16. My new c value was negative 79. So let's plug that into my calculator and figure this out. I get negative 156. I know if the discriminant is negative, then that means that there's no solution. So will the rocket ever reach 100 feet? Nope. My explanation, well, the rocket, it doesn't reach 100 feet because the discriminant is, ooh, there should be another blank right here. Because the discriminant is negative, meaning that the rocket will never reach its height because there's no solution. Okay, so the discriminant is useful for situations like that. Now, again, don't do too much work. Don't actually tell me the answers. You just tell me how many there are.